In this experiment, we are going to be determining the rate law of the reaction that's given at the top. A plus B yields 2C. Substance D is included as a catalyst, and we see that data in the table is including D. So D could be part of the rate law, and we need to find out if it is. So the rate law will have the form D raised to the Z power. So there is our rate law. Now we need to choose experiments to figure out the X, the Y, and the Z. We're going to begin by looking at X. X is the order of the substance A. So we need to choose experiments in which B and D are held constant. Now experiments 1 and 3 hold B and D constant. So I'm going to choose experiments 1 and 3. For those two experiments, I want to take a ratio of rates for those two experiments, and that would be 3 times 10 to the minus 2 molarity per second divided by 1.5 times 10 to the minus 2. That's going to give me a ratio of 2, and what that is telling me is between those two experiments, the rate is doubling. Now I chose to do it in order of the large over the small, so it was experiment 3 over experiment 1. I want to make sure I keep that same ratio as I do a ratio of the concentration of A. For experiment 3, the value is 0.6 molar. For experiment 1, it's 0.3 molar, and that gives me a 2 as well. So in those two experiments, I doubled the A's concentration, and that doubled the rate. So 2 to watt power gives you a 2. Concentration to watt power is going to give me a doubling of rate. Well, X would have to be equal to 1, and we now know it's first order in A. Next, we want to figure out Y. To figure out Y, we need to find two experiments in which the other two substances are being held constant. Now, Y is associated with the substance B, right? So we need to find experiments in which A and D are being held constant. Let's look over here. A and D. Well, in experiment number 1 and experiment number 2, A is held constant and D is held constant. So those are the two that we're going to choose to determine the power Y. Now I've got an empty space over here for me to work on. For Y, I'm going to look at experiments 1 and 2. I again am going to do a ratio of rates for those two experiments. Let's look at the rates. Well, they're both 1.5 for the two experiments. See, 1.5, 1.5. So that's easy enough. Ratio of rates is 1.5 times 10 to the minus 2. 1.5 times 10 to the minus 2. That's a value of 1. We're also going to do a ratio of the concentration of B. That's what we're trying to find a power for, is B. So we come over here and we see that B is going from 0.1 to 0.05, or the other way around. Really won't matter, but I'll do large over small. 0.1, 0.05, and we see we have a doubling. So we say to ourselves, the concentration raised to watt power will give me a rate change of 1. Well, Y would have to be equal to 0. Any number raised to the 0th power gives me 1. And so I now know that Y is 0 and that B's concentration has no effect on the rate. So now we're ready to look at Z. Now for Z, we're going to need to look at A and B and figure out experiments in which A and B are being held constant. Well, let's see here. It looks like experiment number 1 and experiment number, A and, A and B. Experiment 1, definitely. With experiment 4, A is not changing. In experiment 1 and experiment 4, B is not changing. So those are two experiments that I'm going to want to use. We're going to do a ratio of rates So for Z, we're looking at experiments 1 and 4. Ratio of rates, I'm going to choose large over small, 3 times 10 to the minus 2 over 1.5 times 10 to the minus 2. And then I'm going to do a ratio of concentrations, ratio of the concentration of D. So let's look at those two experiments. I did 4 over 1 for that, so I need to do 4 over 1 for the D, and that is going to give me the values of 0.10 over 0.05, and that is 2. So again, we say the concentration raised to what power gives me this rate, and Z would have to be 1. So now we know the rate law. Rate is equal to K. It was A to the first power. We won't include B because it's to the 0th power, and D to the first power. So that's the rate law. Let's see what else is asked. Determine the rate law. We've done that. What is the order of the reaction? Well, the order of the reaction, the overall order, would be 1 plus 1. We don't see those written in, but we know they're there. So it's an overall order of 2, and we'd say it's second order overall. Lastly, it wants us to determine the value of the rate constant K. I'm going to take this experiment and I'm going to solve it for K. Rate divided by A times D would give me K. The rate, I can choose any one of these experiments. So I'm going to choose experiment 1. The rate is 1.5 times 10 to the minus 2. 1.5 times 10 to the minus 2. Make sure you include the units because you not only want to know the value of K, but you want to know the unit for K. In experiment 1, A was 0.3 and D was 0.05. So we'll put 0.3, and this is in concentration, molarity, and D is 0.05. Now if I take those numbers, I'll come up with a K of 1. And the molarity on top will cancel with one of these on bottom, and that will leave me with 1 over molarity times seconds. So the rate constant value is 1, and the unit is 1 over molarity per second, otherwise written, sometimes written, as molarity to the minus 1, seconds to the minus 1. This unit that we see for K is a unit for K every time you have a second order reaction. You will always have 1 over molarity times seconds as your units.